Hello everyone, welcome back to my channel. So in this video we'll see one problem based on PCM. Okay, if you are first time to my channel, please consider subscribing. So I have already discussed some problems regarding PCM and the concept of PCM in my previous videos. If you have not seen those videos, I'm giving the playlist link in the description. Please go there, watch those videos and come back here in order to understand this problem. Okay, right. So message signal he has given as m of t is equal to 4 cos 2 pi into 10 to the power of 3 t. It is sampled at Nyquist rate and transmitted through channel using 3-bit PCM, and you are asked to calculate all the parameters of PCM, and he has given you some sampled values, and he has asked to find the quantizer output, encoder output and quantization error for each sample, and at the last he has asked to draw the transfer characteristics of the quantizer. Okay, so very important problem. So all concepts of PCM are included in one problem in this problem, that is in this problem. Okay, right, so we'll solve that. First question A. So from this m of t is equal to 4 cos 2 pi into 10 to the power of 3t. So what you are getting here is you are getting fm, 4 cos 2 pi fm into t. So general formula is am cos 2 pi fm into t. So fm is equal to 10 to the power of 3, that is equal to 1000 hertz. Okay, so Nyquist rate, and he has given that sampled at Nyquist rate only. So Nyquist rate is equal to the sampling rate also. 1 by ts is equal to 2 fm. So 1 by ts is equal to 2000 samples per second, right? So this is what they, and he has given that it is 3-bit PCM, that is n is equal to 3. N is equal to 3. So when n is equal to 3, we can find L value. L is equal to 2 power n, which is equal to 2 power 3 is equal to 8. And what is delta? So delta is equal to Vmax minus Vmin. So as I have told you in my previous problem, when the peak amplitude is 4, then so Vmax will be 4 and Vmin will be minus 4. Okay, so 4 minus of minus 4 by L value is 8. So 4 minus of minus 4 is 8 by 8, which is equal to 1. So step size is equal to 1. So when step size is equal to 1, what is QE max? QE max is equal to del by 2, that is step size by 2, which is equal to 0.5 volts. Okay, 0.5. QE max is equal to maximum quantization error is 0.5 volts. Then what is RB? Bitrate. Bitrate is equal to n by ts. So n value is 3 into t, 1 by ts is 2000. It is 6000 samples per second, or 6 kbps, we'll call it, we can write it as 6 kbps. So bandwidth is equal to RB, which is equal to 6 kilohertz. Okay, so this completes your first problem. We have calculated all parameters of PCM. Understood? Very simple concept. So I have explained you in this in the previous problem also of this model only. Okay, so if your maximum value is 4, you have to take Vmax as 4 and Vmin as minus 4. This is the only thing which you have to remember, right? Now see the second question. If the sample values are 3.9, 2.2, 0.5, determine quantization error outputs. Okay, sampled value, next is quantized value, encoder output and quantization error. So before we are going to find this, we have to divide that into we have to write the levels, and quantization levels also we have to find, right? So sampled values he is given as 3.9, 2.2, 0.5, minus 3.1 and minus 4. These are the sampled values. So we have to find the corresponding quantized value. So in order to find the quantized value, then we have to divide that into how many steps. So step size of 1, that is from -4 to 4, because maximum value here is 4 and minimum value is -4. That is -4, step size is 1, so it is -3, -2, -1. So next is 0, 1, 2, 3 and 4. Okay, so this is the step. So step size for each and everywhere the step size is going to be 1, because we have got the step size as 1 volt here. So we have got the step size as 1 volt here, right? So any value between 4 and 3 is quantized to 2. So what is the mid value between these two? It is 3.5. Any value between these two is quantized to 2.5. Any value between these two is quantized to 1.5. Any value between these two is quantized to 0.5. Any value between these two is quantized to -0.5. Any value between these two is quantized to -1.5. Okay, so -1.5, I'll write in brackets. Okay, so this is quantized to -2.5, and any value between these two is quantized to -3.5. Okay, now 3.9 falls under this category. Okay, so this quantized value is 3.5. 2.2 falls under this category. 2.2 falls under 2 to 3. Okay, this value, so it is quantized to 2.5. 0.5 is under this category. So 0.5 is under this category, so it is quantized to 0.5 only. -3.1 falls under this category. Okay, so -3.1 falls under this category, so its quantized value is -3.5. Next, -4 also falls under this category, and its quantized value is -3.5. Okay, since there are 8 levels and it is 3-bit PCM, so 3.5 is, so -3.5 is 000 encoder value. I am writing encoder value. -3.5 value is 000, -2.5 value is 001, because it is 3-bit PCM, so we will get 3 bits here. So 001, 010, 011, 100, 101, 110 and 111. Okay, if the quantized value is 3.5, if the quantized value is 3.5, then what is the encoder value? 111. If the quantized value is 2.5 here, so encoder value is 110. Quantized value is 0.5, 0.5 is here, so its value is 100. If the quantized value is -3.5, so its quantized encoder output is 000. Okay, so if the quantized value is -3.5, it is again 000. Then quantization error. What is quantization error? Sampled value minus quantized value. Sampled value minus quantized value. So sampled value is 3.9 minus 3.5 is 0.4 volts. 2.2 minus 2.5 is minus 0.3 volts. Okay, 0.5 minus 0.5 is 0. Minus 3.1 minus 3.5, which is equal to 0.4 volts. Minus 4 minus of minus 3.5 is minus 0.5 volts. Okay, so this is how we can find sampling value, quantized value, encoder output and quantization error if a given problem practically. Okay, so I hope you have understood each and every concept of PCM very clearly. Okay, let me take one more slide. I'll draw the transfer characteristics of this quantizer. Okay, So next we are going to draw the transfer characteristics. Okay, so transfer characteristics of quantizer. Okay, so what are transfer characteristics? Input versus output graph. So input versus output graph of quantizer is called as the transfer characteristics of quantizer. Okay, so these are the input levels, right? Input levels for the quantizer, and these are the output levels of a quantizer. So if you give any input between 1 and 2, you are getting the output as 1.5. so these are the input levels and these are the output levels of a quantizer. So we have to draw the relationship between these levels. That's all. So I'm drawing the relationship now. So for that I'm taking graph. Okay, so -1, 0, -2, -3 and -4, 1, 2, 3 and 4, and here 0.5, 1.5, 2.5 and 3.5. Similarly -0.5, -1.5, -2.5 and -3.5. okay, right. So if you have an input, a value between -4 and -3, it is quantized to -3.5. so all the values from -4 to -3, all the values from -4, this is -4, this value is -4 and this is -3, so all the values from -4 to -3, it is quantized to -3.5. next, all the values from 3 to 2, all the values from -3 to 2 are quantized to -2.5. so it is quantized to all the values from 3 to 2, so this is from 3 to 2, so from 3 to 2 it is quantized to -2.5. next, all the values from -2 to -1 are quantized to -1.5. so all the values from -2 to -1, so this is the value of -2 to -1, so it is quantized to -1.5. similarly, all the values from -1 to 0 are quantized to -0.5. so all the values from -1 to 0 are quantized to -0.5. next, all the values from 0 to 1 are quantized to 0.5. so all the values from 0 to 1, so all the values from 0 to 1, so in this range it is quantized to 0.5. next, all the values from 1 to 2 are quantized to 1.5. so all the values from 1 to 2 are quantized to 0.5. next, all the values from 2 to 3 are quantized to 2.5. so all the values from 2 to 3, this is up to 3, this is from 2 to 3, so this is quantized to 2.5. next, all the values from 3 to 4 are quantized to 3.5. okay, so these are the transfer characteristics of quantizer. Therefore, the important point which you have to note is for uniform quantizer, this is uniform quantizer because step size is constant, right? Step size is constant everywhere, step size is going to be 1 volt only. So for uniform quantizer, transfer characteristics of quantizer takes staircase form, is of the staircase form. Very important point, so very important for all the competitive exams. So for uniform quantizer, the transfer characteristics of a quantizer, of uniform quantizer, of course, takes staircase form. Okay, so this is the staircase form. Okay.